Hello world, here's Jorge, and this is very exciting because we are starting a series on object detection in PyTorch. To do so, I'll be following a practical done by the Visual Geometry group. And here's the GitHub repository where you can find all the very useful information about it. So to get started, let's talk about what is object detection. So essentially, the goal of object detection is to be able to identify specific object classes within the image. And essentially, the key challenge is to find the target classes despite their location and scale within the given image. So to give you an example, let's talk about these frames. So this is extracted from the Tesla AI Day in 2021. And as you can see, for instance, here a target class is the stop sign. So the stop sign has been detected, and as a consequence, the algorithm has drawn a box around it. Okay, so the algorithm has to be able to detect the target class regardless of the location of it. So regardless, in this case, of the location of the stop sign, and regardless of the scale of it. So regardless of the size of it. And this is one of the main challenges of object detection. But let's continue, because we've been talking about an algorithm that is going to be able to essentially perform this object detection process. But what is actually, what is a detector? Actually. Okay, what is a detector? So, a detector is a model that is going to take as an input So you're going to take as an input an image. So an image with given target classes. And outputs. So this detector is going to output a bounding boxed object. So just like we saw with the stop sign, we saw how it was boxed. So that's the output of the detector. And these output is going to come with the position information, so information about the location of this box within the frame, within the image, and also class label. So it's going to, so this stop sign, as an example, is going to have assigned a label. So for instance, 0. So all the stop signs are going to have 0 assigned to it. Okay. Okay, examples. So let's talk about examples of, so just one example, okay? Example of a detector, and that example is fast RCNN. So let's have a look at it. So let's check it out. So fast RCNN in PyTorch. So, as we can see, actually there are model builders for faster RCNN, that meaning that we can utilize the PyTorch capabilities to instantiate a faster RCNN model. And not only that, so essentially we already have a defined class of the model faster RCNN. So we just need to instantiate that class, and not only that, but we can utilize pre-trained models, more specifically weights of these pre-trained models. So essentially we can perform transfer learning on our models. So what is transfer learning? Essentially what we want to do with transfer learning is leveraging pre-trained models to enhance the performance of our own problems, so of our own models. So if you want to learn more about transfer learning, I definitely recommend you to check out the course, so the chapter 6 in the machine learning course done by Daniel Berg, where he really introduces really well the topic of PyTorch transfer learning. Okay, but let's continue with our practical, and let's now talk about, so this is just a very short introduction, and now what we want to do is to well, by the way, just to transform this text into readable text, you just need to press Ctrl M. But yeah, let's continue. So essentially now we want to download all the data that we're going to need for this practical. Okay, and to do that we need to check the repository. So if we go to the repository, we can see that the data is stored in this file, in this tar file, this compressed tar file, and we need to download that. So okay, so one very good question you may have is, okay, Jorge, so when we download a file in Google Colab, where could I find this file? Okay, so this is something interesting, because we need to investigate what is the default say directory that Colab locates you at. So to do that, just let's check at, where we are. So pwd, and as you can see, by default we are going to have all our data located at the folder content. So if we go here, we check content. Right now we just have by default this sample data that comes with Google Colab. Don't worry about that, we're not going to use it. But as you check, when we download data, by default it's going to be located at on the content folder. Okay, so let's start by downloading. So let's start by downloading the data and models, well, also models that are located in that file, in that tarball file. And to do that, well, we just need to, we want to download, so wget, and we don't want unnecessary information to be printed out, basically on the terminal or on the output file. So we, basically to avoid that, to avoid getting information or extra information printed out, we use no variables. And okay, so what do we do next? Well, we need to utilize a specific URL that can be found in the practical file. So it's here. This is the URL that we need. So let's copy paste that, and let's see what happens when we run this cell. Okay, brilliant. So you see how this file, this data.tar.jz, has showed up under the content directory. Okay. Alright, so let's continue now, because what we want to verify is that this file is not corrupted, okay? And to do that, we're going to use a method known as md5sum. So essentially here we're going to have a string, explicitly written string of hexadecimal characters. We're going to have that string compared to intrinsically computed string and see if they match. And if they match, we're going to print out the results and see that it's okay. And if it's not okay, if it doesn't match, then we're gonna we're gonna code to print out essentially that there was an error. Okay. So first of all, let's print. So to print here, we just gonna just use echo, and we need the string. Okay, the explicit hexadecimal string, and that string can be found in the repository. So let's just copy. You see, this is the hexadecimal string, and it's basically written together with the data file, the compressed data file. Okay, so we want to then send that to the following command. We want to send it to md5sum check, which is basically going to compute the string implicitly with this check sum method. And basically, as we are sending this to that method, that is going to be compared. Okay, if that is successful, if the comparison is successful and they are the same, then the file is not corrupted, and we're going to have an OK printed out. But what happens if they are not the same? Okay, so if they are not the same, we are going to need to write an OR statement, in case that it's not. So we're going to write this logical OR operator, so that in case they are not the same, we're going to tell them, okay, so I want you to exit, and I want you to print that there is an error. Okay, so let's see what happens. Let's see what we get. Okay, so yeah, fantastic. This means that our file is not corrupted. Okay, so we can continue. So now we want to extract the information that it's compressed in the tar file. So to do that, we are gonna basically type the following. So we're gonna tar, and we're going to extract the compressed file, the information that is stored in the compressed file, essentially, yes. And how is this file called? Well, data.tar.jz. Okay, that's fine. That is going to yield, as you'll see, a new directory, a new folder, where we'll see, yes, here it is, it's called data, and where all the information has been extracted. So now what can we do next? What we can do next is to basically download a bunch of helper functions. These helper functions are going to be very useful throughout our practical. Okay, so to do that, we're gonna basically need to import it from GitHub. So to do that, we go here, and you see this lab.py. This is the file. This is the script that we want. Okay, this is the script that we want, but to import it, we need to do it using raw data format. So essentially, what we're gonna do is download this file, okay, or this script, again with no extra information printed out. And here we're gonna copy paste this URL, this raw URL link. Okay, so that is the case. Fantastic. So now what can we do? So just check it out. Let's check it out, because we should see now .py, a script lab.py here. Fantastic, brilliant. So let's check it out. Let's check it out. So as you can see, we have a bunch of helper functions, and don't worry about it, because we're gonna go through all functions that are going to be required for this practical. We can explain them carefully, but that will be in the following videos. Thank you very much for your attention, and I am willing to see you very soon.